This video will show you some very basic graphing ideas in OpenTrack. Let's go ahead and load some tracks that we've already tracked here. Let's do an example project. Let's see what that is. Rotary motion. This is a good one. Okay, there we go. So we're now on the tracking screen. Everything's been tracked, so we'll just click continue. And here, let's select some stuff to graph. So, for example, let's do outer and inner marker. I'm going to clear everything, and perhaps I just want to see the X and the Y positions here. So I'll hit plot. You can see something that looks kind of sinusoidal. You can do various types of fit. The sinusoid fit here right now, as of today, the 28th of June 2012, is not working ideally, so I would avoid using it for now until otherwise notified. But all the other types of fits will work just nicely. There are a couple of different ways that you can do fitting here. There's the fitting from within OpenTrack, and there's also JSVG, which is the graphics component. These graphs are all active, so for example, if you click on a graph, you can change colors and things like that. That is independent of OpenTrack, so if you load these graphs in Firefox, you will be able to make various changes to them, even if you don't have OpenTrack installed. Let's focus on the OpenTrack related stuff. So clearly I have this graph, and if I want to get to the next graph that I just did, the Y position graph, you can see it right there. Now, the key ideas here in terms of changing things are gotten to through the Options tab. So here you've got a few options here. Show by frame. So for example, here these frames correspond to start and end frames. However, a lot of times people find it's a little bit easier if they want to say just plot the first 30 frames of data. You would do something like this, and let's change that to 30. And if I click OK, or if I hit Apply All, it will do the graphing. If I hit OK, it'll close this box. So I'll hit OK, and it's redone the plotting, and so here you can see I've only got the first 30 frames of data. I've chosen that. Why? Because I want to show you a little bit of the fitting ideas. You can, of course, do various types of fit: linear, quadratic, cubic, and hopefully shortly sinusoidal. So I'll turn that to quadratic. I'll turn this to quadratic. A sinusoid is not exactly, but almost a quadratic. So let's go ahead and plot those and see what it looks like. So here what you see is that we've got a little bit of a quadratic fit. It's not perfect, it's not bad, and this is the equation of fit. You can see the A coefficient, the B coefficient, and the C coefficient. Notice the plus sign in between. When there's a negative, you'll see the negative right before the number, so just be careful, have an eye to that. The R-squared values are basically correlation coefficients, and if you have an R-squared of over 0.9, it's a pretty good fit. An R-squared of 0.996 or 0.995 is very good. So OpenTrack will do this sort of fitting for you. And of course, if you want to get rid of it, you can just click over here and click No Fit. Some of the other things that you can do is you can plot velocities. Let me go ahead and do that. I'm going to turn off the positions here, and let's go ahead and do velocities. And I want to point out something here that you will see almost all the time when you do velocities or accelerations. In fact, let's do the accelerations as well, just over this brief range. Okay, this gets a little bit bumpy. Generally, with numerical data, there's a rule that for every derivative you take, so if velocity is the derivative of position, you need to do a couple of smooths. And we follow this convention in OpenTrack, but occasionally you'll start getting endpoint effects, things where they look a little bit weird. Do keep that in mind when doing velocity plots or acceleration plots. So here's x velocity, y velocity, and here's the acceleration. Now in the acceleration, we're really going to start seeing endpoint effects, because now this is a double derivative. Same thing here. So be a little bit careful in trusting your acceleration graphs unless you know that you have very smooth data to begin with, and stay away from the ends. Some of the other things that we can plot here, let's turn those off. we can of course plot our links, outer link, inner link, x-axis. When we do that, we have to go all the way down to where we see link kinematics. So of course you can plot the length of a link. This is the distance between the two markers that create the link. The endpoint velocity, how quickly the two markers are moving together or moving apart. The endpoint acceleration. The orientation of the link, that is with respect to the frame. So if I have a given link over here and I want to find out what its orientation is, it's with respect to basically this bottom edge of the frame. That is the video x-axis. So let's do a couple of these here. Length, we'll do endpoint velocity, orientation, angular velocity, and let's do a plot of that. Alright, so here's the length. So you can see there's a little bit of variation here in the length of the links that are created from real markers, whereas there's no variation at all in the x-axis link, because that's defined from static markers. They're not tracked. Go forward, endpoint velocity. Alright, so look at this. This is something that you really want to make sure you understand. Again, it's a derivative, and going back here, there's a little bit of jitter here. The simplest derivative you can have says, alright, what is the slope between those 2 points? This has a negative slope. This has a positive slope. Slightly positive, more positive, negative. So this means that the velocities here, which are based on slopes, are going to jump around, even with smoothing. So that's really what it looks like. We can, of course, if we really don't like what that looks like, we can do some smoothing. I'll show you how to do that in a moment. Let's look at the other plots. So here is orientation, of course. So we go to negative 180, and then we flip over and go to positive 180. It's the range of the function whereby we get the angles. And the angular velocity, see this big jump? We're going to get a huge spike when we look at the angular velocity there. Look at that spike. It is wide because of the smoothing that's already in effect. So again, be a little bit careful. This is not real. Please understand that this is not real. A true velocity would come from this slope or from that slope. So do keep that in mind when you are looking at this kind of data. I'm going to turn off the angular velocity and the orientation here, and let's go back to options. And I'm going to now start doing smoothing. We have all kinds of smooths here. There's boxcar, triangle 5, spline, Butterworth, local regression, and FFT. Gosh, all of these do different things. I will have another video that talks about this, but let's put on a spline smooth to our data. Now it's replotting this stuff. Notice how this has gotten a little bit wavy now. It's wavy, but what that now means is we're going to have a much more continuous derivative, much more continuous velocity. So now instead of just jumping around randomly, it looks like it has some structure. Not all of that structure is real. Again, please do keep in mind there are endpoint effects here, so I wouldn't trust that per se. The best way to get velocity data, so let me get rid of that. Let's go back for a moment. If I want to really get a sense of the velocity, the best way to do it is to get the slope. The slope of the positioning data will give you a velocity. So now I'm going to do a replot. It's a linear fit. And of course this one, gosh, we might as well turn that off because we know that's going to be 0. So let's turn it off and save some space on the graph. Plot it again. Okay, so here we see that there is a slightly positive velocity there. This is angular velocity. That says it's 0.009. And this is now in meters. So 0.009 meters per second, or basically 9 millimeters a second is the change in length. And really, we don't expect that length to change so much. Here, negative 0.001. These are very, very small. Notice there's not a great correlation. Whenever this is close to 0, the correlation coefficient is effectively meaningless here. So these are changing in length, but not really. Any changes in length are due to motion artifacts and tracking. If you want to sort of clear everything, you're not sure what you're graphing, just clear everything, and then you can go back and decide what you want to try graphing. Now notice, I have links selected here. If I go all the way up here and I try selecting exposition, it's not going to happen. I have a lot of people tell me, yeah, your graphics don't work. Well, if I turn these off and now I turn one of the markers on, now I can graph the exposition. So again, do keep that in mind. You've got to select here based on what you have selected here. If you select markers, linear kinematics, linear kinetics, energetics are available to you. If you select something from links, link kinematics are available to you. If you select an angle, angular kinematics are available to you. Now, one other thing is that right now we've set this thing on store plots, and what that means is that over here, when we click on reports, every single plot that we have looked at is here. We can then use that to generate a report. I have another video that demonstrates how that works. But that is done for your convenience so that you don't have to go, oh wait a minute, I generated something and I can't remember what it was. One last thing, let's go back to options. You can always reset your range to the original range. You can go for lines if you want to, turn off the smoothing, and so on. And now when I hit OK, right now that's going to be markers. Notice I have a quadratic fit there, so that quadratic fit's pretty meaningless. Let's turn that quadratic fit off, plot it one more time, and there you have it. So this is the OpenTrack graphing that you can do. Later, once you get into the report editor, you can take advantage of some of the JSVG options. The OpenTrack options override that, but once you're in the report editor, if you need to fine-tune the graph, there are some really cool things that you can do with these active graphs, and I will save that for another video.